I'm Jeroen van den Hoven. I'm Professor of Ethics at Delft University of Technology. In the next 10 minutes, I would like to introduce you to the idea of value-sensitive design. Value-sensitive design is a relatively new approach to ethics of technology, and it provides a useful and critical perspective on ethical issues concerning engineering and infrastructures. Decisions about the design, development and use of technology, from smartphones to airplanes, from ships to power grids, often raise serious moral concerns. They are quite unlike decisions about the order in which to tie our shoelaces in the morning. Decisions about technology can lead to environmental disasters, climate change, chemical explosions, food poisoning and privacy violations. How we may distinguish morally right from morally wrong decisions is the business of ethics, which can be defined as the systematic reflection on and analysis of moral behavior, moral decisions and moral choice. Value-sensitive design tries to move beyond mere reflection, analysis and deliberation concerning value issues in engineering. It looks at moral values as requirements for design. Infrastructures have a number of characteristics that make them of central ethical concern. First, infrastructures are an important feature of modern societies, and the goods and services they deliver, such as clean drinking water, electricity, sanitation and wastewater treatment, have dramatically increased the average life expectancy in the last 100 years. Investments in them are enormous, and the possibility to change them once they've been put in place are limited and very expensive. The things that can go wrong with them are formidable. Secondly, debates about infrastructures typically involve different stakeholders and different perspectives, interests and values. One person's infrastructure may be another person's barrier. A cable may go to your house and not to mine. Internet access may be available in affluent neighborhoods but not in rural areas, or only many years later or at a different price and at different service levels. Some are connected via super-fast communication channels to the real-time stock exchange information at Wall Street and benefit from that in high-frequency trading, where fractions of seconds matter. Thirdly, infrastructures are elusive objects of appraisal. Once infrastructures are in place and working, we tend to forget about them and they recede into the background. This feature has been referred to as structural inversion. Infrastructures are often taken for granted until they break down or their functioning becomes contested or problematic. Then we realize suddenly that they were there all the time. Most of the time we were just assuming that there is safe and clean drinking water from the tap and electricity from the socket. To introduce value-sensitive design, I will give an historical example of the type of thing that can go wrong in designing infrastructures. In the 20s of the previous century, the famous New York architect and urban planner Robert Moses designed large urban projects in New York. One of the projects that he was involved in was the design and construction of a series of overpasses on New York parkways. On the basis of studies of Robert Moses' life and work, we now have reasons to believe that he designed the overpasses at some points intentionally low so that buses from the poor black neighborhoods could not be routed to go to the white middle-class beaches near New York. This piece of civil engineering infrastructure thus had severe social and political implications because it had a racist value, so to speak, inscribed into it. Langdon Winner was the first to describe this, and he referred to this idea by claiming that artifacts have politics. Political goals can thus be achieved by engineering systems. The same ideas can be found in studies of how water management systems in the past were used as instruments to wield power by rulers throughout Asia. More recently, similar claims have been made about net neutrality and the governance of the internet and the geopolitics of gas pipelines between Europe and Russia. We have become gradually aware of the fact that moral values, both the right and wrong ones, can be imparted to technology. We preferably want our designs to be an adequate expression of the right values. Value-sensitive design aims at unpacking this idea. This is the schematic representation of many of our ethical problems concerning technology. On the one hand, we inhabit a world of values, norms, ideals, and principles, and they can concern safety, security, equality, justice, autonomy, responsibility, property, privacy, to name just a few of the most important values. This is the world of morality and ethics. It is a world of prescriptions filled with items that tell us how the world ought to be. It is important to note that this list is not carved in stone, and this list does not have a determinate number of entries, nor do the values listed have a predetermined meaning. On the other hand, we inhabit a world of design, technology, and engineering. It is a world full of artifacts, systems, devices, components, software, but also of processes, organizational structures and protocols, incentive structures, institutional arrangements. More concretely, this is all about electricity grids, highways, hospitals, reactors, computer networks, cities, and railway systems. Ideally, we want the two worlds to be aligned. More specifically, we want our world of engineering and technology, the things that we design, make, and produce, to be an expression of our moral values. But we also want to be able to justify and demonstrate that we have been successful in implementing and expressing our moral values in the things we design and make. Values may be inserted at every step of the design of a technical system, the software, the physical layers, the components and devices. And we should be aware of that at a moment in the design history when it still makes practical sense to think about them. We need thus to learn to design for a range of public values. In order to effectively make values bear upon our systems design, we need to think about values as moral requirements that can be part of a larger set of requirements that engineers work with. Abstract moral requirements, such as privacy, safety, or accountability, may not be helpful in design unless they are specified and decomposed into less abstract and more informative requirements. When we start to think along these lines, ethical debates are turned into potential sources for responsible design and innovation from which requirements may be derived. Value-sensitive design thus provides us with a framework to deal with the ethics of engineering systems by means of the proactive integration of ethical reflections construed in terms of requirements in the early stages of design. The Netherlands has learned interesting lessons about ethics engineering and infrastructures. An attempt was made to introduce smart electricity meters nationwide in 2008. In order to make the electricity grid more efficient and sustainable and meet the EU CO2 reduction targets by 2020, in every household in the Netherlands a smart meter would be introduced. A smart meter is essentially a networked computer that monitors real-time energy consumption per household. It allows both electricity companies and consumers to reduce energy consumption and cut costs by shaving off peaks in production and consumption and engage in efficient load balancing. After many years of research and development and preparation, the smart meter plan was proposed to Parliament. In the meantime, however, the opposition to the proposal by privacy groups had increased. The meter was now seen as a spying device and a threat to the personal sphere of life, because it could take snapshots of electricity consumption every 15 minutes and store data in a database of the electricity companies for data mining. By the time the proposal was brought to the upper house of the Dutch Parliament for approval, public concern about the privacy aspect was so prominent that it was wholesale rejected on privacy and data protection grounds. A value-sensitive design approach applied in the early stages of the smart metering project would have allowed us to come up with a really smart meter, one that satisfied functional requirements that would have helped us make the electricity supply more efficient and more sustainable, but at the same time more privacy respecting. Haven't we made engineering hopelessly complicated by introducing all of these moral values? Are we not running the risk of becoming morally overloaded? We have to design meters that satisfy all functional requirements and serve sustainability, and in addition, they need to be privacy respecting? I don't think so. Moral overload sounds like a tragic condition, but it is a quite common situation where we cannot honor two or more values at the same time. Innovation often is exactly about smart ways to reconcile a range of conflicting moral values in a clever design. Technology in the hands of ethically minded engineers and policymakers can sometimes provide smart solutions to moral value conflicts. The structure of our problem in smart metering is as follows. The shaded area is the area that we are interested in for our moral ideal solution. A first-generation smart meter may neither get us the desired level of privacy and sustainability. The smart meter 2.0 may give us one of these values, but not both. The smart meter 3.0, that is the really smart meter, is the one designed to accommodate both privacy and sustainability above a certain threshold level. It does so because a set of moral values have been taken very seriously right from the start, by considering them as requirements on the same level as the functional requirements. I hope to have shown how moral values can be used in the design of infrastructures if we can think clearly about them in the context and stage where they can make a difference.